If you're like most BAS professionals, BACnet master-slave token passing can be quite confusing the first time you look at it. Hi, my name's Phil Zito. I'm the owner of Building Automation Monthly, and in this week's episode of BAMTV, we are going to be talking all about BACnet MSTP. We're going to go through what BACnet MSTP is, kind of the technical parameters and specifications around it. We're going to dive into how do we tie in other BACnet MSTP devices, and then we're going to talk through some troubleshooting tips related to BACnet MSTP. So let's dive in. Well, BACnet MSTP is one of the most common BACnet networks that is out there in the market. Arguably, it's one of the most common BAS networks that is out there in the market right now, as far as installed base goes. It is, BACnet MSTP is rather, a serial network, meaning it communicates its data in series, one bit after the other, and it uses RS-485, which is a wiring standard, and it is a daisy chain protocol. Now, what does all that mean? Let's take a look on the whiteboard. So if we were to draw a supervisory device, and you should know what devices are from the previous episode of BAMTV, episode 5. If you don't know what BACnet devices are, I recommend you go back and watch that episode. But if we look at a supervisory device that has a field trunk on it, FT, right, or FB, field bus or trunk, whatever you want to call it, coming off of this and going to each individual controller, this would be a daisy-chained BACnet network, okay? So here's a device, here's a device, here's a device, and for good measure, we'll just draw one more device. So we have 4 devices. Now, BACnet MSTP, as I mentioned, is a daisy chain network, meaning that from the starting point to the ending point, it daisy chains from one controller to the other. Unlike LAN, which is a free topology controller, or protocol rather, this is a daisy-chained topology, meaning one controller after the other. That's how you lay BACnet out. Now, there are a couple specifications and technical things related to BACnet, and we'll just go through those real quick because it's pretty straightforward. So each segment, this would be a segment from the beginning of the bus to the end of the bus is a segment, not counting repeaters. So if I were to put a BACnet repeater in the middle here, then this would be a segment, and this would be a segment right here. So a segment can be, per the RS-485 standard, 4,000 feet long and have 32 devices on it. That is the recommendation. Some manufacturers will say more, some manufacturers will stick with that, some will say less. Okay, so that is per segment. Now, on an entire trunk here, and I know, folks, I know that the technical aspects are boring, but stick with me because if you don't have these, then the integration and the troubleshooting pieces of this won't make sense. And that's ultimately what folks struggle with, is the installation, integration, and troubleshooting, because they don't take the time to understand these fundamentals. So this would be our segment limitations, right? So segment. And then our trunk limitations are going to be 1,500 feet and anywhere, I mean, technically you could do 256 devices, but in reality, we're normally at somewhere between 64 to 96 devices. You see, what's going on with these devices is that there's an electrical signal across 2 conductors. So typically like an 18-2 wire. So you've got 2 conductors, and it's going from controller to controller to controller. And that signal starts to degrade over time. That's why we have repeaters, and that's why we have these device and length limitations. It's when you break these limitations that you tend to see degraded performance. Now, there's another thing we need to talk about before we get into addressing and end of line and things like that, and that is this concept called baud rate. Now, per the RS-485 standard, we are required to support 96 and 38.4, 38,400. These are the two baud rates, and this is the communication speed that these devices communicate across the network. Baud is similar to bit, except for whereas bit is on-off changes, baud is symbol changes. So you could have a series of bits that indicate a symbol, and baud would be when you change between those symbols. I'll be honest with you, all you really need to know about baud rate is that each device on a trunk needs to have the same baud rate, and that if your manufacturers are following BACnet standards, they're at 9600 and 38.4. So those are the two most common baud rates. Now you could do other baud rates, but the thing is that like if you do 96.8 or 76.8, which is another common baud rate, what's going to happen, the higher the baud rate, the less devices, the shorter amount of the run, the less distance you can get on your segments. The reason why is that to communicate at that higher baud rate, the devices are going to use up more of the bandwidth of the trunk, and the signal is going to degrade more, which is going to reduce the length, okay? So with that being said, with our segment, our device length, our device count, and our baud rates all being clear now, we have enough information to start diving into addressing. Now, if you've watched any of our courses, or if you've gone and read any of our articles, you've probably heard of Ethernet MAC addresses. That's how you physically address the network interface card on your computers, on your supervisory devices that speak IP, on your controllers that speak IP, and it's a hexadecimal number. Well, the addressing on BACnet is MAC addressing, and it's typically anywhere, let's put addressing over here. So it's typically anywhere between 1 to 256 with, or actually 1 to 255. Let's make that a 5. I always do 256. That's 256 addresses total. And 255 is our broadcast address, which we're just going to call BA. So you should never set a controller to the broadcast address. That is how all your who is and everything gets communicated on the network. Because what happens is these devices, as we'll learn when we start to go through our token states, which you're like, oh my gosh, no. But token states is very important because if you understand that, you'll understand how these devices are going to communicate. You'll understand why addressing sequentially is so important. A bunch of different things. So MAC addresses, we have kind of two ranges, 1 through 127 and 128 through 254. This range, 128 through 254, is specifically required or is allocated for slave devices, and 1 through 127 is master and slave devices. Now, as you recall from episode 5, we talked about how you use services in BACnet, how there is an initiation and then a response. So one device will initiate a service request, excuse me, and then a device will potentially, if it is a confirmed acknowledgement for that service, will acknowledge that service. It'll execute and respond with data if the confirmation requires it for that service. For example, a read property, where you send a read property request to a device, that device returns response data that is the value, the property that you requested information on. Now, here's the thing. Masters can initiate, they can initiate services. Slaves can only respond to services. Okay, so it's not good to be a slave device because all you can do is respond. So typically you'll see master devices in most situations. Let's talk about addressing for a second. I mentioned sequential addressing is really good. Well, what I mean by that is when we address, ideally, we'll address 1, 2, 3, 4, so sequentially. And the reason why is how the token works. So whereas Ethernet frames are the data link, kind of the data unit, the message type for layer 2 Ethernet communication. For BACnet MSTP, for MSTP specifically, the data type is the token. And what happens is this. So this trunk will get a token, and this token is a message, and it will pass in the frame. I believe it's frame ID 1 that is the token. It may be 0. I think it's 1 though. And it gets frame 1, frame type 1, and that tells the device that it can communicate for a certain amount of time. What that means is it can send out its initiates for its services, and what that allows it to do is that allows that device to initiate service requests, and it can then add its data to the messaging. That avoids collisions, because if device 1 and device 2 were communicating at the same time, since this is a serial network, it would cause data collisions, and that would be bad. So to avoid that, the token passes, and we'll just call it TK, from device to device to device. Now the token, when it's getting ready to pass to the next device, it looks at the database and it says, oh, there is another master, which is 2, and another master, which is 3 and 4. And it passes it sequentially from device to device. Now, if this next device was, let's say 7, and this one was 10, and this one was 4 or 2, then it would have to pass the token all the way down the trunk to 2, then pass it all the way back and down, and that is what causes slower communication times. That's why ideally you want to sequentially address your MAC addresses. Now, how do you address? Well, if we were to blow this out real quick and we were to look at a controller, it would have a dip switch, which would be, its address switch. And then you're using binary math, and you're turning these dip switches on or off by flipping them up or down. And then it adds up. So 1, 2, 4, 8, 16, 32, 64. What was that? 1, 2, 3, 4, 5, 6, 7, and then 128. There you go. And that is how you would address this. And you'd flip them on, for the dip switches on, and then you would add up the values, and that would be your MAC address. That is how you set these devices. So logically, we haven't touched anything yet, but physically we've covered our segment lengths, our device counts, our baud rate, and our addressing. Now we go and we talk about the logical things that we need to be concerned about with BACnet, which is device ID, which needs to be unique, and network ID, which needs to be unique. And so we have our network ID and our device ID for each device. Now, the network ID is the entire trunk. Okay, so the network ID would be for this entire trunk right here. Okay, making sense so far? All right, now we're going to talk about the next physical part of BACnet MSTP, which is end of line. You want to set your end of lines so that your trunk knows where it ends. End of line is essentially telling the trunk, you're impeding the trunk with a 120 ohm resistor. And that is telling the trunk, hey, this is where the line ends, so it doesn't keep communicating. So that is why we put end of line resistors on our trunks at the end of each run. All right? So let's say now that we have all of this on here, and I'm actually going to clear off the whiteboard real quick, and then we're going to go through this because I just thought about this. I want to actually draw this a little differently, and we're going to talk about installation, integration, and troubleshooting. So I'll be right back. All right, so let's say that we get put on a new job and we need to install a series of controllers. What we'll typically do is we'll look at the job drawings, we'll figure out where the controllers are, we'll create our network riser, which we cover how to create control submittals in our Design for Building Automation Professionals course. So if you do control submittal design, or you have folks who do control submittal design and you really want to get super efficient and reduce submittal rejections, then really encourage you to go check out that course at buildingautomationmonthly.com. That being said, we have a submittal design and it tells us how we're supposed to lay out our network riser. We hand that to the electrician and the electrician goes to work. First thing we do is we have our supervisory device, and from there we go to our controllers, okay? So first thing we're going to decide is what is our baud rate and our network ID for our BACnet MSTP network. Once we've decided on baud rate and network ID, and we've got our addressing scheme laid out on our job drawings, our installers will go and start to address our controllers. I recommend that you go and you include a kind of, I wouldn't call it a Rolodex, kind of a legend that shows them how to use the dip switches if you haven't worked with this installer before, because that can be a little confusing, and there's nothing as fun as going back into the ceiling and readdressing everything, because that's super duper awesome. Not really. With that being said, we address our devices, okay? So address 1, address 2, we've got our device IDs that are unique for our devices. Those aren't set by the installer, that is set by the commissioning or the setup person. It depends on how you have your BAS organization or your BAS team organized, which, by the way, this is kind of a pro tip here. If you really want to be profitable, outsource your installation as much as possible. Put all that risk on the electrical subs, have them go and execute that, and then focus on the things that you can generate disproportionate profits from. So things like, honestly, I would even train up your subs to do checkout, quite honestly. And I would just focus on graphics, front end, and programming. And you get those things, those are high profit activities, and that's going to generate a lot of profit for your business, which is a good thing. So with that being said, though, these are laid out, our devices are laid out, they're addressed, we've got the trunk speed, we've got the network, we're laying out our wires properly, maintaining polarity, and then we come to the end and we put our EOL on, our end of line. Now, let's say you go to an existing job and it's got something like this and you need to add a BACnet MSTP controller. How do you go about doing that? Well, the first thing you need to do is you need to understand the baud rate. So you need to understand what is the baud rate and what are the MAC addresses that exist right now. Once you have that information, you also need to know the device IDs of the controllers. So you'll have 3 points: your MAC address, your baud rate, and your device ID, and technically your network ID as well. Then we turn off the end of line and we can add controllers to the existing trunk, as long as we stay within that 4,000 feet, 32 device per segment recommendation. And then we add our device, we just continue sequentially adding. And then we put our end of line at the end of the line. Now, what if we had to add a device here? Well, what you can't do is you can't T-tap off with a controller. That is not allowed. What you would have to do is you would have to split this trunk kind of right here, and you would have a new controller that would continue the daisy chain. And now you've got to make a decision. You have to make a decision: do I continue the sequential addressing strategy by readdressing these, make this one 3, make this one 4, and now make this one 2? Or do I just make this one 4, keep this one 2, this one 3 for its MAC addresses, and accept that I'll have a little bit more latency, a little bit more delay on my trunk? If it's 1 or 2 controllers, it's perfectly fine. If it's 40 controllers, that's bad. You should just readdress, because readdressing and having sequential does what 2 things for us? If you're thinking, hey, it increases our speed of our trunk and it makes it easier for us to troubleshoot because everything's sequential, then you'd be absolutely right. So let's move on to troubleshooting. You know, there's been a lot of talk about troubleshooting. A lot of talk, because BACnet MSTP and BACnet IP are things that, while relatively simple, if you don't really understand how they work, and I would argue most people don't, then if you encounter an issue, you can spend a lot of time troubleshooting it. In my experience, having managed a service group, managed an ops team, been the integration program manager for a Fortune 100 company, having installed a ton, having taught a ton, I'll tell you, what really happens out in the field most of the time is very simple to correct. If you're going out and you're like, I immediately need to go meter my trunk, or I immediately need to take an oscilloscope to my trunk and start working on stuff, you're wasting a ton of time. What most often happens from a troubleshooting perspective are these things right here. The first is duplicates. When I say duplicates, I'm talking duplicate MAC addresses, duplicate device IDs. These things right here are very detrimental to your trunks. With duplicate MAC addresses and device IDs, these things can take down your trunks. So that is one of your first issues. Another, and it's signified most of the time by the trunk just going down. Another is baud rate mismatch. So you get a BACnet MSTP VFD. It gets started off by the mechanic. The mechanic puts 9600 baud. The rest of your trunk's at 38.4. And all of a sudden you start having networks that go down. Stuff starts getting slow. This is a sneaky one because depending on where the device is on the trunk, and depending on how bad the baud rate mismatch is, this can be anything from a flapping trunk, something that's going on off periodically, to something that's completely down. So baud rate mismatch is the second most common. The third most common issue, third most common issue is bad wiring. Bad wiring would be, since these are polarity sensitive, meaning that your positive needs to be connected to the same terminal all the way down the trunk run, and your negative needs to be connected all the way down the trunk run. So bad wiring, mismatching of polarity, misusing cables, switching from 18 to 22 gauge, things like that. Having cables that aren't properly terminated to the terminal blocks. Bad wiring is the third most common cause. From here, we move to end of lines. Now, some manufacturers have the capability to put the end of line switch on their controller, and you don't have to use a 120 ohm resistor, you just flip a switch on the controller. Well, sometimes those switches get flipped on accident, and that causes us to have end of lines, which makes the trunk think. So for example, we've got an end of line here, but what if on this new controller on accident, we put an end of line here? Well, this may make the controller think that the trunk ends right here, and you all of a sudden don't see the rest of the controllers. So signs of bad wiring are very similar to baud rate mismatch, kind of flapping trunks, trunks that are slower, data that is slow. End of line is where you've got good communication to controllers up to a certain point, and then after that, the entire trunk's down. That's indicating an end-of-line issue. Now, all of these troubleshooting scenarios, I want to caution you, they're not 100% of the time. It's not always this. However, it is often this. More often than not, if you see the signs I mentioned, it's pointing to one of these issues. And finally, number 5 is shields. We didn't talk a lot about shields, but basically what a shield is BACnet is utilizing shielded cable twisted pair. And the shield protects you from interference from electrical devices. Well, the idea is on one side of the run, usually at the supervisory device, where you've got a panel, you ground the shield on one side, and that takes all that EMF and it drains it out of the wire. Now, if you ground the shield on both sides, that creates an antenna, which actually does the opposite and causes a lot of interference, and that is not good. So we want to go and make sure we ground our shield on one side. Although this is not as common as these. Like, this is the order of troubleshooting commonality: duplicates, baud rate mismatch, bad wiring, end of line, and shield. So there you have it. These are the most common troubleshooting and issues. We talked through installation, we talked through integration, and we talked through what BACnet MSTP is. I really look forward to your comments below the video. Let me know any questions you have. With the BACnet IP video coming up the following week, let us know what questions you may have for that video. And if you're really interested in learning more about BACnet, LAN, and Modbus, encourage you to enroll in our protocols course, where we go much deeper and we dive into all aspects of the protocols. I'll tell you, I wish I had the information in that course back when I was early on in my career. It would have saved me many, many hours, would have helped me be much more profitable for my companies, and would have helped my career. So I really encourage you, depending on when you go to the site, that course may not be available yet, but it will be available within the mid of June. So I encourage you to enroll in that course if it's available when you are watching this video. Thanks a ton. Really appreciate you being here. Can't wait to talk to you again next week. Take care, and be sure to subscribe to this video so that you get notified each week when new videos come out. And you can do that by just clicking on the subscribe button in the bottom corner of the screen. Thanks a ton. Take care.